Now we're going to take everything that we've learned in terms of these reactions and put them together into synthesis. So what synthesis is when we start with something simple like benzene and we introduce a sequence of reactions to make something more complex like a di, tri, or tetrasubstituted benzene. So what we need to do is use our knowledge of the reactions that we've learned as well as the directing group effects to figure out the correct order of reactions. And right now, it's okay, we may end up sometimes forming orthopara isomers in our reaction sequence, and that's okay. So in this first example, we want to start with benzene and prepare parachloronitrobenzene. So if we look at this product, we know the reactions we're going to need. We're going to need to do a chlorination, and we're going to need to do a nitration. So we know the two things we need to do, but we need to figure out the order. That's kind of the important thing here. Well, in this case, it's simple enough. We can try both. So let's say we start with a chlorination. We end up with chlorobenzene. And then let's try the opposite. What if we start with a nitration? We end up with nitrobenzene. So the first reaction gives us the substituent we want, but now we need to do the second reaction. On top, the second reaction is the nitration. And remember that chlorine is an orthopara director. So it will direct that new nitro group ortho and to the desired para position. So we will get the desired product plus the orthoisomer. So this top reaction does give us what we want. Let's come down here to the bottom sequence. So we've done the nitration. Now what if we try to do the chlorination? Here we run into an issue because the nitro group is a meta director. It's going to put that new chlorine meta to itself. So this is not the desired product. This is not the correct reaction sequence. So these are the types of things you want to think about when doing the synthesis. In this example, we want a tri-substituted benzene with a bromo, chloro, and nitro group. So in terms of the reaction, you can write out the conditions, but essentially what do we need? We need a bromination, we need a chlorination, and we need a nitration. In this particular case, there's probably a couple of correct ways you could arrive at the product. But just looking at this, kind of a strategy that I'm thinking about here is maybe I could start by putting the bromine on the ring. That bromine is an orthopara director. So from there, I could put on the nitro group, para to it, and then what that will allow me to do is reinforce where the chlorine goes. So the bromine will direct the chlorine ortho to itself, the nitro will direct it meta to itself, so that last reaction when we do the chlorination will be kind of a reinforced reaction. So let's try that. We'll start with benzene, we'll do the bromination, Next, let's do the nitration. Here, we're going to get the nitro group para to the bromine. Plus, we do also get a product where the nitro is ortho. But this product, we'll just separate it out and discard. From here, now we can take the di-substituted benzene and we're ready to do the chlorination. And the Br will direct to this position, as will the nitro. So you'll get a single product in that final reaction. In this problem, we're trying to synthesize a di-substituted benzene. We have an amino group on the ring and a propyl group on the ring. So there's a couple of things that should immediately pop out at you. First is the fact that we don't have a way to directly put an NH2 on the ring. What we can do is put this on as a nitro group and then reduce. The next thing to think about is this propyl group and the fact that you can't just get this chain on the ring by a Friedel-Crafts alkylation, because carbocation rearrangement would give you isopropyl benzene instead. So this will need to be put on as an acyl group. And we'll reduce that as well. So in terms of the EAS reactions we're going to do a nitration, we're also going to do Friedel-Crafts acylation. Now, we want to think about the order of these particular reactions. So we can put a nitro group on this ring, but once we convert that to an amino group, the amino is an ortho-para director. So if we have this amino group present and we try to do another reaction, it will direct ortho-para, not meta. Additionally, remember, this amino group is not compatible with Friedel-Crafts. Now the nitro group, if we put that on the ring, that will direct meta. But again, remember that Friedel-Crafts is not compatible with nitros. So what does that tell us? That tells us we better do this Friedel-Crafts acylation first. And just a good rule of thumb in synthesis is if you can do Friedel-Crafts reactions as early on as possible, that's usually a good thing. So let's do our Friedel-Crafts acylation. We have this acyl group on the ring. Now we're going to want to reduce this to get the propyl group. But once this becomes an alkyl group, that will be an ortho-para director. We need this nitrogen group meta, but right now it is a meta director because it's a carbonyl. So right now is a good time to do your nitration. So we have these two groups on. We need to do the reductions. And you can do the two reductions in either order. You can reduce the carbonyl first, followed by the nitrogen, or you can do the nitro, followed by the carbonyl. So I'm going to do the carbonyl first, and I'll use the Clemenson reduction. And then I'll do the reduction of the nitro group. For this, I'll just use hydrogen and palladium on carbon. And there's our final product.